Hello students, hope you are fine. I welcome you all on my YouTube channel, that is Competitive Chemistry Circle, or you all aware as CCube. A lot of videos are coming on chemistry topic that are important for the competitive examination like NEET and JEE. I'm getting a lot of messages from the student who are preparing for the NEET and JEE examination as well as the for board. They are facing difficulties in identifying the type of isomerism in the coordination compound. So after a lot of requests from the WhatsApp and different platforms, I decided to make a video or the short video on the topic of isomerism in complex. It is the last topic, or you can say the second last topic of the coordination compound. After watching this video, you will be able to solve your board examination question definitely, as well as for the competitive examination questions. Watch these videos and let's start the video. As you all know that isomer, as the word itself indicate, iso means same and mer means part. It means those compound having the same molecular formula but different structure will be known as isomer. Isomerism, about isomerism you learned in the organic chemistry class 11th portion. Different type of isomerism is there, like structural isomers, stereoisomer, but here we are going to discuss the different type of isomer, not like that of organic chemistry, but the basic definition obviously remain the same. Without wasting the time, moving to the topic, isomer. Two or more compounds having the same chemical formula but different arrangement of the constituent atoms are known as isomer. Okay, same chemical formula is must, but there is a different arrangement, or you can say the different structural formula. Same chemical formula but different structural formula is known as isomer, and the phenomena in which we discuss about the isomers is known as isomerism. Okay, I think it is clear to you all. After that, very important point, you don't never miss this point, that all the isomers are differ from each other in their physical properties. In their physical properties means their chemical properties are identical or same. Why they are different in their physical properties? Because of the different structural arrangement, like color, melting point, boiling point, and the solubility of different isomer may be different, but their chemical properties, the way of reaction remain the same. Okay, except there are few exceptions, but in large you remember that isomers differ from each other in some of their physical properties like color, melting point, boiling point, and solubility, but their chemical properties remain same. I think I am able to introduce the term isomer. Now we are going to discuss about the different types of isomerism in the coordination compound. Basically, dear student, in the coordination compound we divide the isomerism topic into two different categories. The first one is the structural isomer and the second one is the stereoisomer. In today's video, we are going to discuss only about the structural isomer. If you demand about the stereoisomer, I will make a separate video on this. Let's start. Structural isomer having the same structure, structural formula, okay, and you can say, sorry, I'm saying wrong, that is structural isomer are those having the same molecular formula but different structure. There are four different type of structural isomer in the coordination compound. The first one is the ionization isomer. Very simple to remember. Even the words, there is no need to memorize the definition. Even the word itself indicate the difference of the isomer. First one is the ionization isomer. The second is the hydrate isomer. It is also known as the solvate isomer, and the third one is the coordination isomer, and the last one is linkage isomer. Okay, let's start with the first topic, structural isomer. I already introduced the definition, you can take the screenshot. Moving to the first type of isomer, the first type of isomer is ionization isomer. These isomer arises due to the exchange of charged ligand between the coordination sphere and ionization sphere in the aqueous solution. Okay, when we take some coordination compound in the aqueous solution, there is an exchange chemically process there is an exchange of charged ligand in and outside the coordination sphere. I think some of you are thinking about what is coordination sphere. The things that is present inside the square bracket does not participate in a chemical reaction, and these square bracket is known as the coordination sphere. Okay, again I'm going to read the definition so that you can understand it well. These isomer arises due to the exchange of charged ligand, never the neutral ligand. Listen carefully. Never the neutral ligand. You are not allowed to exchange the neutral ligand. Okay. Between the coordination sphere and ionization sphere. What is ionization sphere? The things that is present outside the coordination sphere, or you can say the counter ion. Okay. Now, there is an important conditions to make the ionization isomer. The first, neutral ligand cannot come out from the coordination sphere, as itself the definition indicate that charged ligand is the undergo exchange. Okay, and the important thing that we cannot change the coordination number. Okay, now let's take the example of the first example. See here, the first example we have COCl2 NH3 NO2. Okay, now here in this compound coordination number is 6, but remember ammonia NH3 is a neutral ligand. We cannot exchange this ligand. It means ammonia can never come out from the coordination sphere. So what we can exchange? We have chloride Cl minus or Cl2 here. It is a charged ligand, or you can say the negatively charged ligand. Only this ligand can come out from the coordination sphere, and coming out in such a way that the coordination number could not be changed. Okay, we now what we are going to do, we are making this NO2 inside the ligand. We are making this NO2 to come inside the ligand. As a result, we have to remove one Cl outside the ligand. We have to remove one Cl minus outside the coordination sphere. As a result, what we get is COCl, as one chlorine atom is removed, NO2, NH3 and Cl is out. Now you can see the here outside NO2 is there. Now here Cl is there. It means charged ligand undergo exchange. Similarly, PT NH3 Cl2 Br2 is the same. We cannot exchange NH3 here again because it is a neutral ligand. Now what we can do? PT NH3 ClBr. We are exchanging one Cl outside. As a result, we have to take one Br inside. After that we get this. After that we get this as Cl and Br. It means different ions are producing. Only charged ions can be exchanged without changing the coordination number. Another type of ionization isomer that can be possible by changing both Br inside and both Cl outside. Okay, and one important thing that you should remember, that only a charged ligand can be participated in the chemical reaction, can come out from the coordination sphere. Okay, if I ask the question, dear student, what type of a reaction these ionization isomers show? Can ionization isomer show the test of those ligand that is present inside the coordination sphere? No. Only those ligand that is present outside the coordination sphere or the counter ion will show the reaction or will show the positive test. Okay. Similarly, there is an example as you can see on the screen. Okay. There may be many examples. Okay. After that, one important things, different ionization isomers give different tests because counter ions are different in each case which participate in a chemical reaction. Okay, understood? In this case, see, it will give the test of nitrate ion, NO2 minus. But after the formation of ionization isomer, it will give the test of chloride ion. After that, it will give the test of chloride and bromide ion after the formation of ionization isomer, and before it is showing just the test of bromide ion, and now another example, it is showing only the test of chloride ion. It means, again read this definition, different ionization isomers give different test because counter ions are different in each case which participate in a chemical reaction. Okay, and now For you, I am giving an example that is asked in the NEET JEE examination in 2017. Cobalt NH35Br SO4 is a coordination compound. After that, it can give the test of only sulfate ion as it is present outside the coordination sphere. It reacts with barium, okay, forming barium sulfate as white PPT. It means this form of isomer is showing a white PPT and showing the test of sulfate. Give the test of sulfate. But when we make the ionization isomer of this by taking sulfate inside and bromide outside, then it will give the test of bromide. Br react with Ag, it will form a yellow PPT before it is forming white PPT. So the same isomer is going to show the two different tests. Give the test of sulfate, the first one, and it is giving the test of bromine. Now, before moving to the next isomer, it is better to revise it. Ionization isomers are those isomers that differ in the number of ions, or you can say that differ in the type of ion in and outside the coordination sphere. We cannot change the ligands, and we cannot remove out the neutral ligand while making the ionization isomers. An ionization isomer give the different test due to the presence of the different ions in and outside the coordination sphere. Now let's time to move the next isomer, very familiar to you. The next type of isomer is hydrate isomer. Hydrate isomer or the solvate isomer. Remember there, it is the special case of you can say the ionization isomer, the special case of the ionization isomer, because here we are going to play a game. In this case, we are just playing with water. In the previous case, we can play with any charged ligand. We can play with any charged ligand. This charged ligand can come out from the coordination sphere, and some that is inside the coordination sphere can come out, or those that are already outside the coordination sphere can go inside the coordination sphere to give the different test. But here it is restricted to play with water only. That's why the name is hydrate isomer or the solvate isomer. This type of isomerism is due to the presence of the different numbers of water molecule. What? Different number of water molecule in and outside the coordination sphere. Simply, this type of isomer show the different number of water molecule inside and outside the coordination sphere. Just you have to count the number of water molecule. Take the example. CrH2O6, which is violet in color, Cl3. Here how many water molecule are there? 6 water molecule. All are present inside the coordination sphere. After that, I start to play with water. I remove one water molecule outside. As a result, I have to make one chlorine atom inside to make the coordination number constant, CrH2O5Cl. Okay. And Cl2, here 3 chlorine atom is there. Now 2 chlorine atom and 1 water molecule. Okay, no water molecule, 1 water molecule. Now we can also remove one water molecule further. So we have 4 water molecule inside, 2 water molecule outside, only 1 chloride atom or chlorine outside. Okay, this is pale green. Initially it is violet, now it become dark green. It means by exchanging the number of ligands, number of water molecule, the color undergo changes. Very important question can be generated from this topic. Remember the color, CrH2O6 Cl3 is violet in color. When you remove one water molecule, the color become light green or the pale green. When you further remove one more water molecule from the coordination sphere, it become dark green. Okay. After that, these isomer must be conducting in nature. You are thinking, sir, if we do one chloride atom further inside, okay, if we do one chloride atom further inside, what will happen? All the chlorine atom inside, it could not be possible because it is uncharged. Okay, take the another example. As you can see, it is very simple, similar to the first example. PT H2O5Cl4. See here. Initially we have 4 water molecule, 1 outside, Now we have 3 water molecule, 2 outside. Now we have 2 water molecule, 3 outside. It means different number of water molecule. Another example you can note down are these. Okay. And one important point that I introduced you while taking the example, color change due to this type of isomerism is observed. Okay. Here you can see violet color, pale green color, and the dark color. Okay. Now moving to the third type of isomerism, that is linkage isomer. Very simple, dear student. Word itself indicate linkage, the way of linkage. If the way of linkage is different, then the type of isomerism will be called the linkage isomer. Before starting, I want to show some activity so that you can learn. I have a pen. Okay. This pen cap is connected in that way. Okay. It is one of the way of connecting with the pen cap. And another, I can link it with that way. The same pen cap can be connected to the pen in two different ways. The first is this way, nib closed, and while we are writing, we arrange the cap like that. It means the same pen cap can be connected in two different ways. Similarly, all the ligand cannot have this ability to connect with the central metal atom in two different ways. Only some selected ligand that are known as ambidentate ligand. Do you know what are ambidentate ligand? Ambidentate ligand are those ligand that have two or more donor sites, but at a time they use only one donor sites. For example, I used to take the example of my hands or your hands. We both have the two hands. We use only one hand for writing. Most of you use the right hand for writing. Rarely use the left hand, but you have the two options to write. You are using only one at a time. So you are behaving like ambidentate ligand while writing, while making your notes. Okay, because you are choosing right hand to write, but you have left hand also. In the same way, my case is opposite. As I am lefty, you know that I always write with the left hand. I also have the right hand, but most preferably I am preferring to write with the right hand. So the ligand that have the two option to connect with the central metal atom, but choose one most preferable option to connect with the central metal atom, are known as ambidentate ligand. Not going into the detail, just remember this: Cn minus, OCN minus, SCN minus, and NO2 minus. These are the examples of the ambidentate ligands. Remember these. Okay, what can be happen if it is ambidentate? Its position can be changed like that, NC minus. Okay, and similarly, the most important, I'm not going to take the examples of all. NO2 can be written as ONO. After changing the position of the ligand, I will make a separate video on the types of the ligands where you can take the explanations of this. Now moving to the topic, linkage isomer. This type of isomerism arises due to the presence of ambidentate ligands in and outside the coordination sphere. Okay, if there is an ambidentate ligand, then only linkage isomer is possible. If linkage in the linkage isomer, or you can say if there is a coordination compound and none of the ambidentate ligand is present, then it could never show the linkage isomerism. Take the example: CONH35NO2 Cl2. Here NO2 is ambidentate ligand, so it can be written like that, ONO minus. So these are the examples of a linkage isomerism. Remember, before NO2 it is yellow in color, and after the reaction it become, by changing the position of the ligand, it become the red color. So in the linkage isomerism we observe the change in color also, like the hydrate isomer. In linkage isomer, ambidentate ligand have two donor atom, but at a time uses only one atom to directly link to the central metal atom in the complex, as I already said to you. Okay, such isomer can be distinguished by IR spectroscopy or infrared spectroscopy. It is not very important for the class 12, but you can remember if you are preparing for the competitive examination. Okay, now coming to the topic of coordinate isomers. Coordinate isomer, very simple dear student. Coordinate isomer can easily be identified if there are two coordination sphere. Okay, see here this example, COEN3 FeNO2 6. It is FeNO2 6. Okay, how many coordination sphere? There are two coordination sphere. If there is two coordination spheres simultaneously, then the type of isomer is coordinate isomer. Okay, the type of isomerism arises by the interchange of each ligand. What is the interchange? Interchange of each ligand or metal ions between the two complex ions, that is coordination sphere of the same complex. The condition is the coordination sphere of the same complex. We cannot exchange the ions, ligands or the ions of the two different complex. It should be of the same complex. Okay, and I'm always saying the conditions is important. Both cationic and anionic part must be complex. It means there should be two coordination sphere. Only it is possible only when both are the coordination sphere, because inside the coordination sphere there is a complex part, outside the coordination sphere there is no complex part. So that's why I'm saying both the cationic and anionic part must be complex. Before this type of isomerism, while naming the coordination compound, you see one is the counter ion. It is the simple, it is not the complex part. Here the condition is both should be complex. It means there should be two coordination sphere. Okay, coordination number of both the complex parts should be same, and we could not change the coordination number. It is the essential condition. Here you can see EN, ethane 1,2-diamine, is a bidentate ligand. As a result, its coordination number is 6, not 3. Okay, here the coordination number is 6. What we are doing, dear student, we are exchanging the ligand. One EN coming to this side, as a result 2 NO2 going to this side. You can see COEN2 NO2 2. Okay, take the example more close so that you can understand. And FeNO2 4 En. Now take only one En here, COEN NO2 4 FeNO2 2 En2, and this is the last example. These can be the possibilities of making these isomer. If you have any doubt, you can write in the comment section. I will give you the solution of this. Okay, these are all about the types of the structural isomer. Till now we discussed ionization isomer, okay, where there is an exchange of ions, only charged ligand. And after that we discussed the hydrate isomer, where there is only an exchange of you can say the water molecule only. Okay, and the third we discussed the linkage isomer. The essential condition is the presence of the ambidentate ligand. And after that we discussed the coordinate isomer, the last isomer, where the essential condition is the presence of the two coordination sphere, and we could not change the coordination number in all the different types of isomer. The conditions that we should make the coordination number constant, and in the ionization isomer, and you can say in the hydrate isomer, another essential condition is that we could not remove out the neutral ligand outside the coordination sphere. Hope you understand this video. If you have any doubt, you can ask me in the comment sections or personally in my classrooms as well. And if you have want to have a videos on another topic, you can comment. I will definitely make a videos. I'm happy to see your comments. Thank you so much. Thank you.